Okay, so the first piece of the review, the review works through just like the chapters did. So we're working on our solving and simplifying first. We're working on our solving and our simplifying first. Okay. So we need to make big zeros. We need to make big ones because we see an equal sign. We need to do that. But before we can do that, we have to make sure the sides are cleaned up. So there's not more than one X on the same side or more than one number on the same side. So I cannot start my big zeros and big ones on this number 1 yet because I see that on the left side, there are 2 pieces that have an X attached to them. We need to clean that up first. Cameras, please. We need to clean that up first. So we need to be combining, because they're on the same side, the 15X and the positive 3X. We have to clean that up first. So what's that going to clean up to be? Remember, whatever we don't get done in class, you do on your own between now and 3:30. So the more participation and the faster we move, the less you have to do outside of class. So we have to combine a positive 15X and a positive 3X. So what would happen? A positive 15X and a positive 3X, what would happen? $18X, yes, thank you. So 18X, oops, that's tiny writing. Let me fix that, sorry. And blue. Try again. I'm gonna actually just delete this guy and do over.
And you should, if you're on a tablet, you should not be doing anything else.
Turn
But
off
in
your
Zoom,
sound.
you should not be playing a game. You should not be doing anything else. Same thing for people on laptops. You shouldn't be doing anything else. All right, number 10, ground.
I need you to turn off your microphones. Okay, so now that we've got it cleaned up and there's only one X, we can do our big zeros and our big ones. So we're going to put our line in to remind us we have to move over the line, right? Okay, first piece is always letters if there's more than one letter. So if there's a letter on both sides, then we have to worry about it. Is there a letter on both sides? Is there a letter on both sides? No, so we don't have to worry about moving the letter first. We have to get rid of what's with the letter, but doesn't have a letter. So we need to big zero this -7. So how are we going to big zero a -7? How are we going to big zero a -7? Add 7 where? On both sides. Okay, so I'm going to add I'm going to change colors so I can see what I'm doing. +7 to the 7, right? I'm going to copy it. I'm going to add a +7 to the 43. Because whatever you do to the left, you have to do to the right. Okay, and you have to be doing the opposite. That's what turns it into 0. Because -7, +7, 0, that's all gone. Okay, what's left on this left-hand side? If we big zeroed that 7, what's left? $18X. And it has to equal what happened to the other side, the 43 plus 7. 43 plus 7 is not 53. Guys, you know you have access to a calculator. Utilize it. Some of you are not doing that during the tests and the quizzes and stuff, and you're getting wrong math answers, and they're simple math answers, so just use your calculator. 50. Okay, I'm done with adding and subtracting, so the big zeros are finished. Okay, no more big zeros because there's no more adding and subtracting on either side of the equal sign. That's how you know when you move on to your big ones. Okay, I need to big one this 18 away from the x. So what do I need to do? How do I big one that 18 away from that x? What am I going to do math operation wise? What am I going to do math operation wise? Divide both sides by 18, exactly. So 18x divided by 18 has to equal 50 divided by 18, because that's the rule. I have a big one that happened because 18 divided by 18 is the number 1, and I don't care anymore about it. So I only have an x on the left-hand side. I only have an x on the left-hand side. I need to simplify the right-hand side. I'm not going to use decimals. I'm just going to simplify. What divides into 50 and 18? What can simplify 50 and 18? I'm looking at what can I divide into 50 and 18 so that it becomes a simpler fraction, not a decimal, a simpler fraction. So what multiplies to make 50 that it could also be used to simplify 18? Think about what makes 18, because it's the trickier of the two. 2, okay? So if I divide both of these levels by 2, what is my new fraction going to say? What's my new fraction going to say if I divide both levels by 2? $50 divided by 2, what is it? 18 divided by 2, what is it? What would the simpler fraction be? I don't think 18 divided by 2 is 4. I do agree with the 25. I don't agree with the 4, because 18 divided by 2 is not 4. 9. And we leave it like that. We don't have to change it. We just have to simplify it. Okay, next one. Do I have to worry about any big zeros? Do I see any adding or subtracting happening in this problem? Number 2. Do I see any adding or subtracting happening in number 2? No. So I get to go straight to big ones. Okay, because I have no adding and subtracting, I go straight to big ones. Okay, so I need to big one out of there, this 20. So what am I going to do to big one out that 20? What are we going to do to big one that 20? Divide both sides by 20. So 20x divided by 20 has to equal 120 divided by 20. This is a one-step problem. That's why you didn't see any big zeros in it. It went straight to big ones. Okay. I've big zeroed out this 20. I big one'd out the 20. Sorry, I said that the wrong way. So what's left on this left-hand side? X, and it has to equal whatever we happen to the right-hand side. So 120 divided by 20 is what? 120 divided by 20 is 6. Okay, so there's one final answer. Here's the second final answer. Question 3. Simplify the expression. Simplify the expression means I have to go ahead and do my distribution of my outside number to my inside number. And then I'm going to either color code or use the table to clean it up from there. So we show our distribution. 7 times an x plus a 7 times a positive 6 plus a 2 times a 14 plus a 2 times a negative x. Distribution. Okay. I distributed the outside number to each piece. I distributed my outside number to each piece. Okay, and my outside was a positive 2, and my outside was a positive 7. That's why there are plus signs in there. So now we're going to go do the math. A 7 times an x is a 7x. What's a positive 7 times a positive 6? What's a positive 7 times a positive 6? You're the ones making more stuff for you to do after class. What's a positive 7 times a positive 6? 42. But it's what kind of 42? Because we need a sign in there. We need our signs. Positive 42. So it's not just 42. It's not just 16. It's not just 12. It's positive or negative. You've got to give those signs. Okay. So this says positive 2 times positive 14. What would that be? Positive 2 times positive 14 is a positive 28. Thank you. And I have a positive 2 times a negative x. What's that going to be? Positive 2 times negative x. What are we going to get for that? Positive 2 times negative x. Keep reminding you, everything we don't get to in class, you guys finish on your own. Negative 2x. Okay, so now I have to look at combining things that are the same. So I'm going to color code. Pink for my x's. You could choose a different color. Remember to include the sign. And I'm going to use green for my numbers. Remember to use the sign. Remember to get the sign. So we're going to combine like colors, combine like terms. So that says a 7x minus a 2x. What would we have? If it was a 7x minus a 2x, what would we have? 5x. And then the middle says positive 42 with positive 28. So I know it's positive. Positive what? Positive what? Use your calculator. Positive 70. And it's done. They only wanted you to simplify. There is no equal sign. You cannot do more than that. That's as far as it can go. Doing it again. We have to distribute these outside numbers to the inside pieces. So we're going to go do that. That's telling me a 4 times an x and a positive 4 times a positive 2 and a positive 3 times a positive 6 and a positive 3 times a negative x distribution. Then we go do the math. If I have an x times a 4, what am I going to get? If I have an x times a 4, what am I going to get? What is an x times a 4 going to get us? An x times a 4, what's it going to get us? Four x, okay. And then I have a positive 4 times a positive 2. Positive 4 times a positive 2. Because if I did what Moses said, this is what I would do. And I think there's something missing. So we need our signs. I don't know why I have to keep saying, use your signs. Positive 4 times a positive 2. What will we get? Positive 8. Positive 3 times a positive 6. What do we get? Positive 3 times a positive 6. What would we get? Use your calculators if you have to. Positive 18. And then 3 times a negative x. So what would we get? 3 times a negative x. So what would we get? Negative 3x. Okay. So then now we have to go ahead and we have to combine our like things. So orange for x's this time for me. I don't care what yours are. With the sign, make sure you take the sign. And I'm going to do another color for my y's. I think I'll do blue for my numbers. I have to combine like things. That's why we're color coding them, so we know which ones are alike. We always start with the letters. That says 4x minus 3x. So what would we get? 4x minus 3x. What did we get? I would get an x because I know as soon as I see it, there's an x there. Okay, and then I have a positive 8 with a positive 18. What do I get? Positive 8 with a positive 18. What do I get? Positive 8 with positive 18. What do I get? Positive 26. Okay, it's done. We are just simplifying. There is no equal sign. We cannot do anything more than that. No worries. I think that you just were hearing negative because your answer would be if we were subtracting. Okay, we're just simplifying. We're not solving. It doesn't say solve in the answer. Okay, so now we're on this one that says that we have to select the ordered pair that satisfies the equation. So what we have to do is we have to check which one of these is going to work for this equation. So first step, we rewrite the equation. Y equals negative 3x minus 1. Okay, and we have to go plug these in. The first number is the x. Let me move it, it's in the way. First number is the x. Second number is the y. We're going to put them into the equation and see which one works. Yes, we're checking them all. Because there are some that are multiple choice that are multiple answer. So if you don't check them all, you will not get credit for the question because there were multiple that were the correct thing. Okay, first one's the x, second one's the y. So I'm going to put them into the equation. So we start with the first one. My y says 14. Has to equal negative 3 times my x of negative 5 minus 1. Okay. So 14 has to equal, what's a negative 3 times a negative 5? What's a negative 3 times a negative 5? What's a negative 3 times a negative 5, guys? Use your calculators. Stop wasting our time. Negative 3 times negative 5. So what are we going to get? Make sure you use the signs in your calculator. Negative 3 times negative 5. What do we get? So close, Vanessa. Super close. But a negative times a negative doesn't make a negative still. Negative 3 times negative 5 would get me what? Positive 15. And then it says minus 1. Okay. So 15 minus 1, last time I checked, is 14. Right? So that one works. Now we're going to check the next one. Okay. 10 equals negative 3 times negative 5 minus 1. 10 equals 15 minus 1. Does that make sense? No, that says 14. So that one did not work. So even though the first one works, you have to check others because on some of these multiple choices, it's going to be choose all. So we're going to get in the habit of checking all. I'm changing up the colors so I can tell which one I'm working on. So we're going to go check the next one. This one didn't work, and I'm going to show you what to do with it in a second once I get the color changed up. And I'm actually going to move him over here. And we're going to show that this one did work, right? But this one didn't work, so we cross out its equal sign. We're going to check the next one. This says that 5 has to be equal to negative 2, correction, negative 3 times negative 2, because that's the x, minus 1. All right. What's negative 2 times negative 3? That's -2 times -3. Guys, remember the ones we don't finish together, you have to do on your own. So we're not even done with the first page. Okay, there's no X there. It's just 6. We've gotten rid of the X by plugging in that -2 for the X, and we've gotten rid of the Y. Okay. Okay, so that says 6, and then it has a -1. So 6 minus 1 is what? 5. So that says 5 equals 5. It worked. Notice in the instructions it says, select all ordered pairs that satisfy. Multiple choice is not just A, B, C anymore. Pick one, done. Multiple choices, check them all. That one worked. So now we go check another one. We're on D. So 7, let me change up the colors. I'm trying to change up the colors between so we can tell where one ends and when the next one starts. 7 equals -3 times 4 minus 1. That didn't change colors, this should be blue. Okay, so what is -3 times 4? -12. So this says 7 equals -12 minus 1. Does that make sense? What is -12 minus 1 equal? What does -12 minus 1 equal? -13. So that's not going to work. That's no. So we're going to cross out its equal sign. We're going to say 7 equals -13, and we go get the line, and we say no. Okay, so we got to check our last one. Oops, not what I wanted. Push the wrong button. This one. Okay, we're on E, which says -13 equals -3 times 4 minus 1. Because we substituted in the X for its spot and the Y for its spot. But this should be a 3, not a 4, sorry. Okay, so -13 equals, what's -3 times 4? What's -3 times 4? -3 times 4 is not 16. -12 minus 1. What was -12 minus 1 again? What was -12 minus 1 again? Come on, guys, what's -12 minus 1? Okay, -13. So that says -13 equals -13. What are we going to put? Check mark or slash? check mark. So now we have to go and mark our answers. Okay, now we have to go check mark our answers. Let's put our negative 13 equals negative 13 here. So how many were actually ones that worked? How many were ones that worked? How many of the ones we just worked out, checked out? 3 of them. So when you go do your test, you need to make sure that you are marking that A worked, right? You need to be sure that you're marking that C worked. That's where the X was -2. And we see that X of 4 and Y of -13 worked. All 3 of those have to be checked for you to get credit for that question on the final. So don't mess up. And once you found one, I'm done. Because this keyword right here in the instructions that says the word all. Okay. Okay, now we're going to go do our equation. We're using our equation and we're grabbing our slope, our growth rate. Where do we find our slope? All the time, our growth all the time. Where do we look? Where do we look to find our growth rate? Where is growth rate attached? Who gets to have the growth rate? The slope, that's right. So the slope, that's what I'm asking. Where in the equation do I find that slope? They gave me an equation. They want me to grab the slope. They want me to grab that M out of there. So what am I going to put as my answer for this first one? What's our slope for the first one? Because it's attached to the X. Our slope is 2, which means what? +2 divided by +1, right? That's what our growth tells us, our change of Y over our change of X. Yes? Okay, so we have to do the second one. What are we going to say? Set it up the same way. Okay, I need to see the whole thing, including the change of Y over change of X. So what are we going to say? Lily's close. She just didn't finish it. Where's my change of Y over my change of X? Yes. So our M is -4, which means that I have a -4 dividing by a +1, right? That's my growth. Now, this last little piece here that says, which is a greater growth rate, does not have anything to do with the sign. So pretend like there's no sign on it. Which one has a bigger change? We're not saying positive, we're not saying negative. Which one has a bigger change? Does A have a bigger change or does B have a bigger change? The sign does not matter. Which one has a bigger change, A or B? Is changing more, B. So part B has a bigger change. How did we know why? Because What did we see happening? Because remember, we don't care about the sign when we were comparing changes. So what did we see happening? Which one is a larger number? What part of it is a larger number? Because remember, we have our change of y and our change of x. We're worried about that piece of it. Because they both had the same change of x, it looks like to me. So what piece was larger? We could say the absolute value of the change of y is larger for compared to 2. Okay, and we should say absolute value so people don't wonder about the negative positive stuff. Okay, so we're on our next one down here. We need to do a proportional statement. We need to do a proportional statement. This is way back. So it says that Mark mows 9 lawns, 3 hours, and they want to know lawns per hour. So that is telling us that we have to put the lawn number on the top, divided by, because per hour means the hours on the bottom, and we solve it. How much does that equal? What's 9 divided by 3, guys? This is a straightforward question. We should be done with it already. 3. So our answer, Mark mows 3 lawns per hour. This is the answer, not the math. Okay, which equation represents negative 2x plus 5? So first thing, which one can we totally just like not even close, cross it out? It's not even right. Of the 3 pictures, which one is a definite not right? Because y equals mx plus b is only for linear. So we know that this one is not a line. So it's out of the options. Okay, so we have to compare the other 2. We have to compare the other 2. Okay. So to compare the other 2, we're going to draw in our slope triangles. We're going to put our coordinates on. I'll make this a little bigger so I can see it. Okay. We're drawing in our slope triangle. We're putting our coordinates on just like we've done. So this is not new stuff we're doing. Oh, you are. I'm just pushing the wrong thing. Okay, we got to go put a second coordinate on. That has 2. That now has 2. We got to put our coordinates next to those. So what is the coordinate for this top one? What is the address on the graph for that top one? What is this one's ordered pair? 0, 4. 0, parentheses, 0, 4. And we have to do this bottom one. Goodness gracious, that's gigantic. And it changed colors on me. Should be blue. There. How about this bottom one? What's that one going to be? Yep, parentheses 8, 0. Okay. Now we're going to go put the coordinates on the other graph. Over here. What's the first coordinate? What's this top coordinate going to be? Zero, 5. Parentheses 0, 5. Okay. What's the bottom one going to be? Down here. What's this one? One, 3. Okay. So then now we have to look and compare them to the equation. Okay. Now we have to look and compare features to the equation. First thing, let's put our format for the equation above. So what is the format for our linear? What's the format look like? What's our format look like? Yes, y equals mx plus b. Okay. The n is our growth triangle. So let's put our growth triangle in. We go straight down from the first coordinate. Oops, not what I wanted. I want the line. Switching. Straight down from the first coordinate to the location where straight across from the second would make a triangle. There's my slope triangle, right? Same thing on this one. Straight down from the first coordinate. Straight over from the second coordinate. Ooh, that's too much. Too much, sorry. I only need to go to right there. Straight across from the second coordinate, slope triangles, right? Maybe. Okay. What does the up and down of the slope triangle tell us? What does the up and down of the slope triangle tell us? What's the up and down on the slope triangle tell us? I just need the up and down, so I only need one of those pieces. So which one is the up and down of the slope triangle? Is the up and down of the slope triangle the change of y, or is the up and down of the slope triangle the change of x? I just need one of the pieces. Change of y. Let me put this down here, actually. change of y, right? What's the sideways tell me then? If the up and down tells me change of y, what does the sideways tell me? Change of x. Okay, same thing for both, right? So I'm just going to copy and paste these over. Copy. Paste. Copy. One second. This one should delete. Copy this guy now. Paste him. Okay. So we have our change of y and our change of x, right? All right. That'll get us our m, right? Change of y over change of x. That gets us our m. What gets us our b? So the slope triangle would get our m. What gets us our b? Where do we see b? On our pictures all the time. So to me, these both look like they're negative. So the slope isn't helping me yet. Where do we get b on our picture? Where is this b coming from? If we're looking at a graph, where does the b come from? Where the x is 0. So we have to look at where the x is 0, comma, what did it say? What did the equation tell me? 0, comma what? Look at what's highlighted. 0, comma what? 5. So that must mean that right here, oops, I gotta fix something. I don't want you to have fill because you're messing things up. But right there is our B. And here is our B, right? Those are our B's when our X is 0. But the equation told me my B had to be how much? How much did the B have to be? It sounds funny. How much did they want us our B to be? 5. So which one am I going to mark is my correct graph? Which am I going to mark is my correct graph? This one is. Because the B matched and the slope matched. Okay. Not doing too bad. We might actually finish, like, so that you don't have to do extra outside of class. Because too many of you just don't, for some reason, think it's okay to just leave it and get half credit. Okay. So we're working on our next thing. It says evaluate. And it says X has to be -3. So I'm going to put a -3 where the X is, but I'm leaving the rest alone. So the 21 is still there, the negative still there, the 2 is still there, but in parentheses, I'm putting -3 because that's what they said. Replace the X. That's what evaluate means. Replace the X with what we tell you. Okay, so we got to go do the math. What is -2 times -3? What is -2 times -3? Make sure you use your signs. What is -2 times -3? +6, yeah, +6. Then we do the math. Okay, do the math. What's the answer going to be? What's the answer going to be? 27. Good job. Okay, done. Need to change this back. It's bugging me. Okay. Next one. Same kind. They're telling us to replace the X and replace the Y with the numbers we tell you and tell us what the number answer will be. Okay. Replace the X and the Y and tell us what the number answer would be. So we start with X is 3. So I have to put parentheses 3 and it's to the second power, right? Because that's what the equation, that's what this expression tells me, X squared. Plus 4 parentheses -2. I replace the X in the expression with the number they told me. I replace the Y in the expression with the number they told me. I now get to do the math. Okay, what is 3 squared? What is 3 squared? What is 3 squared, guys? 9. And then I have to do a +4 times a -2. What would that be? +4 times a -2. What would that be? -8. So now we'll go do the math. What's the answer? If we do the math, what's the answer? 1. Okay. So all they wanted you to do was replace the X's and Y's with what we told you. Tell us the number that would happen if the X was this and the Y was that. Okay, who remembers this? What would we do? Give a hint. What are we doing? Cross multiplying, yes, way back from chapter 1. Okay, so this says a 5 times an X, because we look diagonal, has to equal a 3 times a 100. Okay, so a 5 times an X, what do we get? The 5 times an X gets us what? A 5X, exactly. That has to equal the 3 times the 100, which gets us what? 300. And then we have to big one it, because I see an equal sign, I see a number in front of a letter. I need to big one out this 5. What do we need to do to make that 5 big one out of there? What do we need to do to get that 5 out of there? Divide both sides by 5, exactly. So 5x divided by 5 has to equal 300 divided by 5. And we do the math. Because we big one this guy out of there. What's left on the left-hand side then? What's left on the left-hand side then? Just an x, and it has to equal our answer, which is what? 60. Don't overthink those. Okay? Don't overthink those. All right, last one. We have to solve. Big ones and big zeros again because we're solving. Okay? When we see simplify, not solving. Okay? Not big ones and big zeros. So I have to look at it. Is this cleaned up enough? Do I only have one number and one letter on either side? Is there a side that has more than one of something? Yes, this left side has more than one. It has more than one of these numbers. So we have to combine the numbers. If they have more than one of the letters, we have to combine the letters. Okay. So we need to make it cleaned up so there's just one number and one letter at most. Okay, so if I combine those, that says positive 26 and positive 8, what would those combine to? Positive 26 and positive 8 make what? 34. And then we have a minus 3x, and we have an equal 9x. Right? We okay with that? Okay, so now we're going to do our big ones and our big zeros. Which are we going to do first? A big one or a big zero? How do you know when you're supposed to do which? Which do we do first, and why are we doing it? Big ones or big zeros come first? Big ones or big zeros come first? Do big ones or big zeros come first? When we looked at our list and our steps to take, which did we do first? Big ones or big zeros? Which have you been doing first the whole day so far? Big ones or big zeros? Big zeros, and that's because I see a subtraction or an addition. We always do big zeros when we see subtraction and addition still left, okay? So I have to get those X's together. I agree with that. The problem was that's not going to be a big one. Because of that subtraction, we have to big zero it. So the way you know whether we're big zeroing or big oneing, big zero has addition and subtraction still. Big one does not, okay? So we're big zeroing. How are we going to big zero that 3x out of there? Negative 3x out of there. What are we going to do to big zero that? What are we going to do to big zero the negative 3x out of there? Add 3x to both sides, yes. So let me get the 3x over here. Oops, I got to set to that. Wasn't on the equations, huh? Add 3x to the left. Copy. Did the wrong thing. I did a paste. Add 3x to the left, so you have to add 3x to the right. Whatever you do on the left, you have to do on the right. Both sides have to stay in balance. Okay, I have big zeroed this 3x out of there. What's left on the left-hand side? What's still here? The 34. And that 34 has to equal whatever happened to the right-hand side. So what happened on the right-hand side? How much is there? 12x. Okay, do you see any more adding and subtracting? Do you see any more adding and subtracting? No, so now we're gonna big one. Whatever's with the x, big one. So what do we need to do to big one? That number that's with the x out of there. Divide both sides by 12. Yeah, so we have a 34 that's being divided by a 12, and it has to equal, oops, I forgot to arrow out of it. It has to equal a 12x that's being divided by a 12, so that we big one, that x out of there. I mean, the 12 out of there. Okay, and we had one of these happen before. Does this divide evenly? No, so we're going to just simplify the fraction. First thing, we're going to put the x first. Okay, we're going to put the x first. And we have to simplify a 34 divided by a 12. What can divide into both 34 and into 12? What can divide into 34 and into 12? So I'm going to get my symbol for divide. What can divide into both 34 and 12 to simplify this fraction? 2. Okay. So now we got to clean it up. Figure out what 34 divided by 12 is over the 12 divided by 2. Correction, 34 divided by 2 over 12 divided by 2. What's my new fraction that's simplified going to say? Because it will be a fraction. It did not go in evenly. You're not doing decimals. You're doing simplified fractions. So if I do 34 divided by 2, what's the top going to say? If I do 34 divided by 2, what's the top going to say? 17 divided by, and 12 divided by 2, what's the bottom going to say? And that is our final answer. It's not going to get better than that. You're not going to worry about it getting better than that. It's okay that it's a fraction answer. Things don't always come out beautiful. Fractions happen in the world. In fact, fractions happen more often than whole numbers do. It's really a weird thing if a whole number comes out more often than not. Okay, so you should be done. So hit turn in.